So this webinar is on the subject of Docker, because we're starting to see Docker appearing in automation projects, and we're starting to see automation products coming out with Docker versions. And this webinar is in partnership with our supplier In.Re, who provide us with the OPC router software. And today's webinar will be presented by myself, Dave Hammond, the Senior Product Manager at M.A.C Solutions on the communications products, and also my colleague Jan from In.Re. So if you'd like to just introduce yourself, Jan, that would be great.
Yes, thank you, Dave. Yeah, welcome everyone also from my side. As Dave said, my name is Jan Jebens. I'm working at In.Re, partner of M.A.C, and I'm working here in the pre-sales department as a solution architect. So basically, companies get in touch with us asking for a solution for a specific project requirement, and then we try to provide solutions and also do the complete process to proof of concept, and providing solutions. And also we're doing webinars here in the pre-sales department to providing information about our products and other topics just like today.
Okay, thank you very much, Jan. So just a brief word about the intended audience for this webinar. The audience that we have in mind for this is an audience of automation engineers who may have heard about Docker or seen products or seen applications where Docker is involved and want to know a little bit more about what Docker is and what it isn't as well. The object of this webinar is not to make you a Docker expert in 30 minutes, but it's just to give you an overview so you can understand whether it's going to be something that you want to explore or something that you don't want to explore. So we'll take you through a few of the basics of Docker, the structure of Docker, because it is different from things you may have come across in the past, and it's a learning curve for all of us. So we'll be going through what is Docker. We'll be comparing Docker against Windows VMs. We'll be having some questions around Docker and things that you may have in the back of your mind around the use of Docker. Jan will be doing a little bit about Portainer, and we'll be looking at some applications where OPC router and Docker and Portainer are combined together, some real-world topologies where this has been used. Jan will then do a demo, and then we'll talk a little bit more about Docker tools if you want to explore things in your own time away from this webinar to get to know Docker some more. And then right at the end, we'll have some questions. So what is Docker? Docker has come from the IT world, and it's been used for some years as a containerization platform used by software developers. So it's open source, and the idea is it's a way of packaging applications into containers, into standardized units called Docker containers. And with those Docker containers, you can then deploy the applications in a consistent way, no matter what hardware you're running on. So the Docker container itself is, as it says here, a lightweight standalone executable package. So inside that one container, you have the code, you have the runtime engine, the system tools, the configuration files, and all the settings that go with it. So it's a self-contained package of code which can be moved and run on different sorts of platform. You can have several containers running at the same time, and they will share the file system and system resources on the device. And you can also dictate to the different applications which ones have access to which resources, so you can allocate resources. So the idea of Docker is that gives you a consistent way of running applications on different types of hardware, and you can move it from hardware to hardware, operating system to operating system, and it runs the same way all the time. So as I've said, because you can move it across different platforms and different hardwares, it can run uniformly and consistently. So it doesn't matter if you're running on Linux, you're running it on top of some other OSs. There are some other ones that you can run Docker on. It'll run in the same way. So in terms of development, you can develop it and you can test it in one environment and know that it'll run in other environments. Because the Docker code is all self-contained and you put everything together to run in one encapsulated container, the actual resources required to run the same type of application are much less than you'd need for a traditional server running a VM with Windows. Another advantage of Docker is that the applications themselves are isolated from each other and they're isolated from the infrastructure. So it gives you an element of security between applications. So each application is running in its own silo. So all of these things all rolled together means you have a means to create quickly and relatively easily an application that you can roll out for lots of different environments on lots of different hardware, and know that once you've tested it in one environment, it'll run robustly on other ones and consistently and reliably, and because it takes fewer resources, also very quickly. So how does the Docker platform fit together? So there's a number of components inside Docker. You have the Docker desktop. Now that is a special environment which you need to install for Windows and Mac in order that you can create a virtualized environment that you can run the Docker on. You don't need it for Linux. But Jan later will be doing a demo and he'll be using a Windows machine. So he'll be running Docker desktop initially to show you that. The other components, so you've got the engine, which is the main core of the software. You have what's called the daemon, which is the kernel that manages and runs the images and the containers, that basically orchestrates the operation. Interfacing with that daemon, you then have a command line interface. So a command line interface, for those people who remember DOS or who use Linux already, it's typed commands. In order to make things easier than having to remember and type these commands in, there are tools that will help you to sort of automate that and make that simplified and visualize that, and that's what we'll come on to later when we get onto the area about Portainer. You also have a REST API which allows the applications when they're running to interact with the daemon. I hope I'm pronouncing that correctly. The container itself is the encapsulation of the environment, and then you have what's called an image. Now the image is what's called an immutable image. It's unchangeable. You can't once you've compiled it and set it, it's not changeable. So when Jan later on will show you OPC router inside the Docker environment, he'll be loading in an image, and that image is something that has been created and compiled by InRay of the OPC router software, and you can't change it in the same way as you can't change an executable that you might get from a supplier which you then install in Windows. Hanging this all together, you've then got the registry, which is the storage area for images, and then you can also have images inside images, so they can be nested. So that's the overall structure of the various component parts that fit together. If you look at that diagrammatically, you'll see at the heart you've got the Docker, outside you've got the daemon, which is running that, the API for interactions between applications, the command line interface for interactions between users, and also then to help put a nice friendly GUI on top of the command line interface, you'll have Portainer, which is, again, we'll show you later. Portainer is an add-on tool which is separate from Docker, but it's used with Docker and other virtualized environments. And again, Jan will be talking about that in a little while. So let's compare how an application might run in Docker compared with how an application might run and the environment it would need for Windows. So on the left-hand side, you'll see a virtualized machine, again, typical Windows machine on the left-hand side. You'll have the physical server, you'll have the hypervisor, the OS, which is, again, typically Windows, and then you'll have the virtual machines. You can see you have a lot of resources required because you actually have the entire install of a Windows 2019 server or something, the whole of the operating system to run your application on top of. So it's quite a heavy utilization in terms of resources, in terms of memory, and also it takes a long time to boot. If you compare that with Docker, you actually have a very small amount of memory required because it's all self-contained. You have a very quick boot up time. And so because of that, you can run it on much lighter, much cheaper, much less capable and less powerful hardware. And you're starting to get automation devices which are considered to be edge devices, or even some of the higher grade PLCs, which actually have the capacity to do this. So we're starting to see more and more of this virtualization in the Docker, a lightweight Docker method, being able to run on lighter hardware, which is, and as that hardware gets gets more powerful from the automation devices, they're sort of meeting in the middle there, and so you'll start to see these more of these things coming through on PLCs. You're already started to see Docker on top of code assist, for instance. So these things are worlds are starting to merge. So putting in a table form, how would you run these two things side by side? How would you compare side by side the Windows and the Docker application? So typically on a PC, you'd be needing at least 8 gig of RAM, an 8-core CPU, fast CPU, a terabyte of storage. If you compare that with a Docker hardware, you can see a small amount of RAM. You might need only an ARM processor, not very fast, not much storage space. The hardware for a Docker application would be small, so it fit in a smaller footprint in a panel. It could be thin rail mounted. It would be much less expensive. You wouldn't need the price of the cost of the Windows operating systems, so you're not having to pay for that. There would be a fast boot. You'll be also, with the tools that come with Docker, you'll be able to use that far more easier than some of the Windows tools to be able to manage that system remotely. When it comes to applications, people that are bringing out applications which are designed to run in Docker as well as Windows, they're bringing out a Windows version and then a Docker image, and that's what OPC Router have done. That's what the guys at InRay have done. The configuration, if you look at some of these applications which are designed for both environments, they typically now have a web GUI. So the GUI will look the same whether you're configuring the Windows instance of that software or whether you're configuring the Docker instance of that software. And that's the same with OPC Router. Because of these advantages in the right-hand column here, low-cost hardware, they're good to remotely manage. It is very suitable for large-scale deployments. Now, some of these large-scale deployments may be remote, but some of these may be actually inside a factory, whereby you might have dozens and dozens and dozens or hundreds of the same machines, and you want to be able to manage those all using a cookie-cutter approach of creating one build and then rolling that out and managing it. So some of these applications are coming from the IT staff in factories wanting to manage a very large estate of duplicate machines on their shop floor and being able to do that in that fashion. And some of these applications are more where the requirement is to put a small, low-cost, lightweight piece of hardware in a remote location. And both of those applications are suitable or can be suitable for Docker type applications. So coming into this webinar, you probably, if you've not aware of Docker and you've not seen it used in any applications, you may have some questions around its suitability for automation in the first place. So some of the questions you might have, it's new. Well, it's new to automation engineers, but it's actually not that new in terms of the IT world. It's been around for quite a while. What is happening, what is new is that it's starting to butt up against the automation world. So we're starting to see people who are doing projects which are crossover projects between IT and OT, and in that environment, you can reuse the skills and the tools that IT people have got in the form of Docker and Portainer to potentially help with automation projects and make them easier to run. There is a learning curve, obviously. It's Linux based, so you need to understand about that. And as I said, the purpose of this webinar is not to make you an expert, it's to give you a framework to decide whether you're going to go down the route or not. But there are nice tools to use to help with de-skilling the process. And again, we'll talk about Portainer in a little while. OS, some people will, just because the very fact that it is Linux based, will not like it because they will consider that a security risk. That's down to your personal preference as to whether that's something that you're happy with. There are lots of companies that use Linux as a standard, but there's lots of companies that don't. So that's a choice which is often dictated by enterprise policy. So as you move on to these applications which move across IT to OT, one of the things you have to be careful of is not to compromise the security of the entire stack. Because if you're putting applications in which are on the OT side, which are using IT tools, perhaps if they're being managed from the IT side, you have to make sure that you're not punching a hole through the DMZ that could potentially be seen as an attack vector for viruses. But that's something that again, we can look at that later. Portainer helps you to do these things by using outbound ports and such like. So it does, to a certain extent, tools that you can employ will help with that. When it comes to the images themselves, as I mentioned, OPC Router have created a Docker image in exactly the same way as they would create a Windows exe for install. And once you have those images, those are trusted images and they can't be changed. If you're using some of the free trusted images on some of the Docker forums and things such like, I think there's one called Docker Hub, then obviously it's down to you how you feel about using those. But there is a huge number of applications which are pre-done, which you can simply take and reuse. But again, that's your choice as to whether you want to buy these things, want to use free ones. That's your choice, and again, down to the policies of you and your customers and your enterprise folk. Determinism is another question we've been asking. How reliable is it in terms of its cycle times and such like? Because it's a small install, it's more reliable, more consistent than a Windows application running the same thing, because it is running so much more lean. But you're not yet seeing applications whereby PLC code is running in Docker. And that's for a good reason. That tends to be kept to one side, and then Docker may be run in parallel with any control code. It is, however, very reliable. You can configure it to run independently. Each of the applications runs in its own silo, so you have an element of management and policing between which resources have access to which applications and so on. And because of some of the management tools, again, I keep mentioning Portainer, but it is very, very key. You can also employ tools to make this is a very usable application if you have a large-scale deployment. So now I'm going to pass across to Jan. So I'm going to mute myself, and Jan's going to talk about Portainer.
Yes, thank you, Dave. So yeah, as Dave mentioned Docker, or told you about Docker, and we thought in the context of Docker, we would also give you some basic information about Portainer, because everyone who comes across Docker at some point also meets Portainer. So if you could switch to the next slide. Generally, yeah, can you switch to the next slide, please? Yeah, so as an introduction, what Portainer is, so it says it's a centralized container management platform. It was usually, in the first place, it's an open source software. It was very much used by people in the home automation, and it has a great community, and it is basically, it helps you to manage all your containerized applications. So particularly when you have not only one or two, but multiple containerized application running, then you need a central management for that. Portainer is not necessary, but especially not if you get started. So you can do everything by the command line interface. You can deploy a container and manage it and update it and so on. But Portainer gives you a graphical user interface. And that makes it very helpful, of course, for also getting started, but particularly when it comes to managing multiple applications for enterprise solutions. So OPC Router, for example, is an application that is a middleware, and it's used in different locations in production facilities. And if you get to the point where you have to not manage only one or two applications in a container, but let's say 30 or 60 and even more, you need a management platform for that. So on the next slide, there are some bullet points regarding Portainer. So as I said, instead of using a command line interface, it provides a central management platform here, and it reduces, as it says, the complexity for command line instructions. It gives you information about the status of all your applications, the containers. So you have a dashboard and you see what's going on. Also, it's a good way to learn and use Docker, because it's not only deploying an application, but you can also directly dive into the container, connecting via a command line interface. You see the logging of an application. And this way, it's also a good way to learn it, to learn about Docker using Portainer. So the general architecture, I will also show that later, is you have a central server from where you manage and administrate everything. Let's say you have 100 different devices where you have different containerized application running. Portainer uses the server and agent approach. So on the remote machines, being edge machines or Linux virtual machines, so our edge devices, you install the agent, and the agent is then connecting directly to the central business platform or the management platform. So that's the basic architecture. And as I said, there are different things you can do with it. I will give you a demo of it later. Not only managing the images and so on, the containers, but or directly deploying a container. The magic starts here when we're talking enterprise, managing multiple installations. Because updating, as we will see later, an application to a new version whatsoever, or rolling it out in the first place, is done basically by a couple of clicks. And that's why, first of all, we will present something about Portainer, of course, to you, but also give you an example of a use case where you roll out an application, in our case, of course, OPC router, to different machines with a few mouse clicks if you want. And that's the major focus when we do projects with multiple installations of OPC router. That's how we roll them out. And that's why we decided to give you an impression of how to use it. Thank you.
Okay, thanks, Jan. That was great. So what we're going to do now is look at a few applications that are the sort of early adopter applications of OPC router in Docker. And typically these applications are doing some sort of integration between the OT world and the IT world. So we're going to go through a few of these. You won't see a lot of detail in terms of the customer and the application, because many of these are subject to NDAs. So some of the information about the specifics of the industry or the customer has sort of been removed. But it'll give you an idea of the flavor of the type of application where this has already been used. So this first one is actually a handling application in the transport industry, whereby a customer has hundreds of machines installs, standalone machines, around the world in lots of different environments or lots of different countries, and they want to have one way of centrally managing and centrally deploying one instance of the same set of tools worldwide. The application is actually interfacing between a PLC, in this case it's a Siemens PLC, which is running OPC UA. So they're putting a small cluster of small PCs down on the site, and that cluster is obviously giving them resilience on that site and no single point of failure. They're running OPC router in that cluster, and then that OPC router is able to do interactions between the PLC instructions, the PLC code, and the enterprise MES, both on the local site, but also passing the data onto the central systems. And that's all done via a custom API interface, and the OPC connection to the left to the PLC is done using OPC Router's OPC UA client plugin, and the connection to the custom API is using OPC Router's REST plugin. So OPC Router is acting as the middleware. Also, it's acting as an orchestrator to do a sequence of functions inside, handling the instructions from the MES and passing it down as instructions to the machines, and taking data from the machines and passing it back to the MES to be logged and archived away. So the idea of this is the hardware is low cost and small. The cost of installing the OS, there isn't. It's running a free OS. You have the cost of the OPC router software, and so you can put together an application which is easily managed across dozens and dozens and hundreds of different installs in a relatively inexpensive and robust way. And this is being driven from the IT people at this particular customer. And so this is a crossover IT OT project. This second application is an application where a customer makes machines. They make machines that do inspection systems, and on the site they want to take data from the results from those inspections of each item as it goes through, and they want to send that to an MQTT broker on the site, whereby that data can then be integrated to a central point. The customer themselves is very aware of security, so they want to make sure they're not running a Windows application. So they've decided that a Linux OPC router installation will actually be more obscure to anyone who would like to attack it than perhaps a Windows one. The data is being sent here is a small amount of data. It's running very fast, and the MQTT protocol lends itself very nicely to that, and the use of Docker lends itself nicely to that, and the OPC router OPC router image in Docker is again, it's lightweight and can handle some data in a very quick way. The hardware itself is low cost, and it also means that these machines can be deployed from the center using Docker tools such as Portainer, so that the installation of the machines is to a large extent de-skilled from the local engineers. And now I'm going to hand across to Jan, who's going to talk about a couple of applications that they've seen in Germany.
Yes. So yeah, the first use case here is a company that is operating worldwide, different locations, from the hygiene and medical industry, and the project was to integrate the machines with the MES application. So the integration layer was an own-built MES system, and the integration layer was a database system, and we would send data from the MES down to the machines, and the way back collect data during the production process and send it back to the MES. Actually, there are many different protocols used. We also have REST here. The communication down to the machines is OPC UA, and different plugins of OPC router, but basically it's an MES. So classic IT OT integration. And we started doing the proof of concept on Windows, which was successful. And at some point, we began to roll out to the different locations. And over approximately 1 year, we would be ready to, well, we had all locations connected and rolled out our OPC router to all locations. And then it began that they had to make updates because OPC router has new features very often. And there were many occasions where they had to update the OPC router application. So there is a central M.A.C. team that is doing that for the worldwide, actually. And they would have to do a remote desktop session to a Windows machine, uninstall OPC router, install the new version, and do that on the redundant OPC router installation as well. So each location has 2 OPC routers working redundantly to secure M.A.C. integration for the production process. And then they had to do that multiple times for each location worldwide. And then they saw a video that we provide on our webpage about Partena, our partner, who did a webinar on how to roll out OPC router to 50 installations, so 50 different devices. And then they saw how easy it would be to upgrade, manage an OPC router installation remotely. So the major point here is why using Docker is the ease of handling, updating process, and so on. And that's why they switched to Docker. That's the major reason, because it's basically as easy as it can be. So yeah, that would be here. And the next use case on the next slide. Here, it's also a worldwide operating company. It's basically, it was machine data capture only. So they're doing different consumer goods that they produce on a large scale, different locations. And they would capture machine data for quality analysis and general production analysis and would send it via MQTT. And they decided not to have virtual machines. I mean, generally, there are 2 basic concepts. You have 1 or 2 OPC routers running redundantly for a set of machines. Or you have 1 OPC router, for example, only for 1 machine, depending on the amount of data, the load of data, and also, of course, the time sequence. There are different architectures, but basically you have an OPC router installed, and they have for 1 machine so much data that they would have an edge device. They would directly connect it to the 1 machine, install OPC router. An OPC router would then pump all the data into the cloud because of the high amount of data. And for each machine, they would have an edge device with OPC router. And because of that, they also have multiple installations of OPC router, which they have to manage. And that is, the best way to do it centrally using a tool such as Portena. So that's why they decided to do that. They have OT people who are able or who learned how to set up Docker on this Linux-based edge device. They are the people who are connecting everything. They're the electrical engineers, if you want, and they are able to simply prepare that edge device, connect it to the machine, deploy OPC router, and the only thing they have to do is to talk about the firewall rules, but no heavy server blades to be installed, usually also by the IT department and all that. Instead, you have light hardware, if you want, an edge device, and you can simply directly connect it. So they are the masters of how to do it. And that's why they did this architecture, each machine having an edge device with OPC router, and then also Portena. So that's why, and we can continue.
Thank you. Yeah, that's great. So What we're now going to do is I'm going to stop sharing, and Jan's going to start sharing his screen, and we're going to see a demo. During that demo, what Jan's going to show us is the Docker desktop, and then a little bit about Portainer and how OPC Router is used in Portainer, and some of the tricks and tips and tools that Portainer can be used for.
Yes. So let me share my screen. So everybody, you should now see a Windows Server operating system, the desktop.
Absolutely. You can see your blue screen perfectly. Thank you.
Perfect. Yeah. So yeah, as Dave said, first of all, Docker Desktop, basically a virtual Linux running as an application. You are on a Windows machine, any kind, you install Docker Desktop, and you have a virtual Linux under it that can run containerized applications. There are some interesting features here, like managing the images and so on, volumes, persistent volumes where data is stored, such as data, user data and so on, that must not be deleted. But generally, you start here and you can install and run containerized applications. So on Docker Hub, for example, or if you're going to some other companies that provide that, you get the information how to do it. Basically, if you have installed a Docker Desktop, you look on Docker Hub for the command that you would run here. So there's usually you would pull an image down, which is the application, and then you would deploy it. But you can also directly say, use the Docker run command. And then depending on the application, the vendor would give you some additional information, like here you have to provide a username and a password. Think of the ports maybe, because it's a container. It's running in the application is running a container. It has to communicate with the outside world. That's why you have to have some port forwarding. But that's basically it. You have an internal and an external port. You type in the information. And once you have the command ready, that's it. You would open your command line, which is a Windows PowerShell, and then run that command. Now, of course, I already have downloaded the image because it's often a couple of 100 megabytes and more. And if that is the case, then you see OPC router is now installed. It takes a couple of seconds. It's ready to use, obviously running, so we are fine here. And then, yeah, you just go here, and at some point you can, since I specified this port 8080, it would let me sign in, and now I'm ready to start. So that's really everything. Install Docker Desktop, get some information about the command and run it. And that's your first step.
I just want to stress here, I just want to jump in for a second. The web interface we saw of OPC Router is exactly the same OPC Router interface you would see if you're running a Windows instance. So if you're familiar, if you're familiar with OPC Router in Windows, then coming out the Docker version, you shouldn't see any difference.
Yes, except for decom technology that is not available under Linux, but yes, the rest is the same, absolutely, of course. Yeah, okay, and then the next one is Portainer. Here, for example, or maybe I can quickly delete it. So now my OPC router 5 doesn't exist anymore because I deleted it. So you can do everything, programming via the command line interface if you want to, that's fine. But you can also use Portainer. Portainer is an application that is also running, as you can see here, in a container. And what you can use it for is you run 2 commands and then you're done. You have installed it. You provide a username or a password for the admin user, and then you get the screen here. So on the home screen, I have all connected devices. The local is my Docker desktop. And then I have connected 2 edge agent, 2 edge devices running Linux somewhere in our network. And those 2 devices are running an edge agent of Portainer, and it's directly connecting to this Portainer business server. And then when I click on it, it's connecting now to the external environment, and you see there are containers running on that edge device somewhere in the network. The same on this second one. And on my local machine, I have also 4 containers. So OPC Router 5 that we just installed, I can remove it maybe here, and then it's gone. In the first step, instead of running a command, Portainer offers you app templates. So you dive into the device you want to install it on or deploy it on. In this case, my local one. And then you go to app templates. And then there you find a list of many images from different companies that you can directly use, because if I search for OPC router, I don't have to care about the command. I can just say, okay, OPC router app template maybe. And then of course networking here would be for your bridge at the moment. And then I need for my application a username and password, probably very often the case, but you just follow the steps here. Keep in mind, maybe there are things like ports, the internal port and the external port. How do I get into the container from any system and out? So just keep in mind you have to do it at some point, and then usually they run also by default, and they maybe put it like this. Some ports specific to OPC router here, and then you say deploy the container. And then now I have an OPC router running here with a different name the same way without the command line. But that's of course not what's so interesting. It's helpful, but the magic starts here when we talk about different devices. Portainer offers a video where they have 50 devices. That's quite impressive. So I have 2. Nevertheless, what you do is you have all the devices connected to your central instance of Portainer, and you would build groups. I have only one group called Edge devices, and I've assigned both devices to that group. So this is a logical grouping, maybe the location worldwide, different departments within your factory and so on. So a logical grouping, very helpful. And when you've done that, you build stacks. In this case, I've built one. I call it GitHub because I'm pulling the information from a Git repository, because I'm not only installing OPC router or any application here. What I do is of course, I install OPC router, but at the same time, I'm giving a configuration file. So maybe really quickly here. I have a Git repository. You can store everything locally, but here I have some OPC router configuration. All my data flows, connections to machines, MQTs is stored in one file. And I have a Docker Compose saying, deploy the application with that project file in a certain way with some environment variables. Where am I, which time zone, and so on. Username, password. And here I defined deploy OPC router to all devices in my group with the configuration I specified here. Can also be locally. In this case, it's GitHub. And I provided environment variables. That means I can have 100 OPC routers with the same configuration rolled out to 100 edge devices with one configuration, but I can also change the configuration. So that's where the magic starts here, because I'm now rolling out the configuration to 2 devices, but the first device is the primary OPC router and the second one is the secondary OPC router. They're running redundantly. So I can configure everything I want with Portainer and not only install it. And if I say pull an update, then it's doing it at some point. So it says success. And now it's deploying in the background. So there's it says deploying, and at some point it will be successful, and then I have 2 OPC routers running redundantly because I could provide configuration files. And when I switch into my edge device number 1, that takes some time sometimes, yeah. And then dive into containers. Then you see you have the Edge OPC router, GitHub OPC router. So within a couple of seconds, it's rolled out, but it's rolled out with a configuration, and it would now start, transferring data. And that's when you have 100 installations worldwide, and you have to manage them centrally. That's where this, such an application like Portainer becomes crucial, I suppose. So, yeah, that would be it, just to give you an impression of Portainer, I guess. So let me stop sharing my screen, and then, Dave, I hand over back to you, I guess.
Okay, thank you very much. So that was the demo where and Jan was just showing you the Docker desktop and how you could use command lines, but also how you could use tools. And Portainer is one that's almost universally used. So yeah, that's something that you should, if you're going to dive into it, and you could use Portainer as an easy way of, or an easier way to get your head around the new technology and how these things are organized, and having to learn lots of command lines. So if this has whetted your appetite for exploring this further, then there are lots of other resources you can go and look at. Some of these tools are away from the content of this webinar and the purpose of this webinar, but certainly you could go and look at Docker Hub, you could look at Docker Compose, you could look at Kubernetes, which is another virtualized, containerized environment. Again, this is not covered in this webinar. And also you could look at Docker Swarm, which is a way of using a number of PCs in a sort of clustering arrangement. So that's coming towards the end of our webinar now. So this has been a webinar by myself, Dave Hammond of M.A.C Solutions. We're the UK agents for the OPC router software, and also Kepler software, and also other OPC softwares. So contact me on that email if you'd like to talk any applications. And Jan is one of the experts at InRay who's helping us this morning, and we'll obviously have Jan at our disposal as well to talk with you about any applications that you might have to want to explore. So thanks very much for your time.